So one of the challenges you can do is the one called Mastermind. Now the challenge is to generate 4-digit numbers. Okay, so you want to generate a random 4-digit number. The player has to keep inputting 4-digit numbers until they guess the randomly generated number. Now after each unsuccessful attempt, okay, they should try again, but you need to say how many numbers they got correct. Not the positions, just the numbers, okay? So it's not which position they got right, it's just which numbers, okay? So how many of the numbers. At the end of the game, it should congratulate the user and say how many tries it took. So to do this, we're going to need a couple of bits of code. One of them is how to generate a random number. So we want to be able to run this. So from import rand_int. The number equals rand_int, and it's going to generate a random number between 1 and 10, and then print the number. So if I just run this, you'll see that it just comes up and it says just 7. So that is the random number that's generated. Now if we were going to do that for our coding, you'd want to make sure that you only had 3-digit numbers in there, for example. So you might want it to generate a random number between 1000 9,999, and then if you run that one, you see that it generates a 4-digit number for us. So that's a way to get the computer to generate a 4-digit number. The next thing we're going to want as well is we want a 4-iron range. Now the reason we want the 4-iron range is because we want to be able to repeat this process more than once. So it's going to check basically to say, is the first number the same? Yes or no? Is the second number the same? Yes or no, etc. until it gets it right. So with this code, you've got 4-iron range. So I is essentially the variable. So basically, I want it to generate the numbers 0 to 101. Now when you run this, you'll see that it doesn't actually include the final number. It includes the first number, but notice that it stopped at 100. Okay, so it doesn't include printing that final one. So on here, it started at 0 and then ends at 100. The other piece of code we're going to need is not equal. Now this will determine whether a number is equal to another number. So computer number equals 10, and then the user's going to enter a number. Now I've made this that they are strings, so I've basically forced these numbers to be recognised as strings. The reason for that is you cannot compare two numbers in this way with this method. You have to actually use it as a string. So you can convert them to the string. They still can be converted back to numbers again if we need to, but we're going to use them as strings. So what we've got here is it asks the user choice one number. So we've got a choice of one number here, okay? So let's say if computer number is not equal, that's what the exclamation mark and the equals means. So if I put 9, for example, 9 is not equal to 10. It is not the same number. However, if I run this again, we will then see that the numbers are equal. So it means that they are recognised as the same number. Now, what I'm going to do is I'm going to show you how to just get started with these masterminds, and we're going to end up. So what I'm going to do is show you how to just get started. Actually, close that quick. Close him. Close him. Okay, so what I'm going to do is just show you how to get started with these. So I've got my new document. So nice fresh start. It's always a good idea to explain at the top, so I'm going to use 3 speech marks just to talk about what this program is going to be. So Mastermind, so just an introduction. Player will choose a 4-digit number. This is then compared to the computer's number. Okay, so that's compared to the computer's number. This will then and the game ends when the numbers are the same. And the computer number and player number are the same. Okay, so just go back to the top there, and then I'll just add my 3 speech marks there just to end it, so you can see it's no longer a string now because it's no longer green. Now, the first thing we want to do is we want to import, so we're going to need random. So we're going to do from random import randint. Okay, so that's our first one. So just to test this out, I'm not going to show you how to do all of this. I want to show you how to do the first part of this, and I want you to kind of build on those skills to try and solve the problem yourself. Towards the end of this video, I will show you my example of what I have created if you're really struggling and not sure what to create. Okay, so let's say that the computer number for this case, I'm actually going to give it a number. The reason for that is it means that we can actually test to see if this is going to work or not, because we don't want to sit there for ages just coming up with random numbers to see if we've got the same number as what the computer wants. So it's really important that we know which numbers it's going to work with. So if we want the user to come up with a number as well, so let's say we'll call it user number. So the best way to do it is to have a capital for the first one, for the first letter of the word, and then a capital for the next word, so you can see that it's user number. You can use underscores. The issue with underscores though is if you accidentally did 2 underscores, or you did an underscore with a gap and things like that, it's not a suitable variable. So it means that you could end up with issues in your code and it would take you a very long time to find it. So a good way to do it is to not include spaces, just do a capital letter at the start and a capital letter at the next word. So this one is going to be input. So this is the user's input now. So select a 4-digit number. Okay, so a 4-digit number for them. And that's going to be user number. Now what we want it to do is we want it to basically compare the numbers. So we're going to say if computer number, so if the computer is equal to user number, actually capital there, then it's going to do something. So if it's equal to that, you're going to say print the, let's do print to the outside, print is the correct answer. Okay, so that's the correct answer. And then we can just do else. So if it's anything else, if it's not equal, you can just put print not equal. Okay, so something like that. So just save that. Put this in my documents quickly. Python. Yeah, I'll just save it in here and I'll just call it Mastermind. So let's have a look. So select a 4-digit number. Pardon me. Now what we'll see on there is you'll see this is not equal. So it's coming up here. Now the reason it's coming up as saying not equal is because it is not comparing them correctly, because they are not the right type. So what we want to do is we want them to be strings. So if I then make this string and I make this string, so 1, 2, 3, 4, Now you'll see that it comes up with the correct answer. That is because strings can be compared to each other, so it knows that it is an equal value. You can't tell if a number is equal to another number. So if I had, let's say, okay, so you can't tell basically if two numbers are the same. So we've changed them to strings, so it accepts that as a number and a string, so it will check to see if it's correct. Now part of this, it's all well and good checking if it's the right answer. Okay, so we've got the first part, but now if we run this and I did, let's say I did 0, 0, 0, it's not equal. Okay, excellent, thank you very much. So that doesn't really help. We need it to be able to loop. Okay, so what we'll do is we can add a while, and this is where we can add our not equal. So while computer is not equal to user number, it's going to loop. Okay, so I've got while computer not equal to user number, and then I've got my colon, so then tab across, tab, 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 because I want it to repeat all of this as a loop until it gets the correct answer. Now, user number is not defined. Now what's happening there is it's asking me, I'm basically comparing user number before user number's actually been selected as a variable. So if we simply fix that by putting user number at the top and just set it as the game starts, it's always equal to 0, it means that it will go past the loop because it knows that it's not equal to that, and it can't ever be equal to that because the number that we randomly generate will never be 0. If you want to make sure that it will never ever happen, you can always make it -1, because it's impossible in this code for it to end up as -1, because it will never hit a negative number. So I'm just going to put it for 0 for now. Now if I then select, let's say I did that for example, this is not equal. So it's going to keep repeating my code until I get the correct answer, which as we know should be 1, 1, 1, 1. Okay, so we've got this number. So that way we've tested it. So it's really important, especially when you're doing your final coding, that you test this as you're going. Don't write pages and pages of code and then test it, because all of a sudden you'll get errors everywhere, and that's when it doesn't help. So we could have got a false error if I hadn't noticed that the strings couldn't be compared. Okay, so it's really important that you test it as you're going through. Now, what we want to do is we want to have a look at this coding, and we want it to actually compare each individual part of the number to the number of what the user has input, basically. So you can compare numbers. So if I added a piece of code here, so you can actually compare parts of strings. So you can say if computer, and let's say 0 equal to user number 0, print numbers match. Okay, so the idea is that what it's doing is it is looking for position 0. Now remember that because the use of coding, 0 is a position, so 0 is actually the start point. So if we have 0 and whatever number is 0 in computer, so number 1, if it is also number 1 in the user's number, it will print user's numbers match. Okay, so let's go here. If I did 1, 1, 1, okay, that is the correct answer, and the numbers match. It knows that position 1 and position 1 match. Now, of course, you could go through and end up with pages and pages of code that will say if computer position equals and then else print number didn't match. Okay, so you can do it like that. So if I actually went through, I will disable this first bit of the code though, because it's not going to work if I start changing it, because we'll never get out of the loop. So I'll just add a couple of hash symbols at the front there, and add one here as well, and then go from there. So it's coming up saying that the int is not subscriptable. Okay, now when it's saying int isn't subscriptable, it's basically saying it's a number. So remember, like I said before, that's what error will come up if you've tried to compare a string and a number together. It doesn't work. So what we want to do is we want to make this a string. So I'm going to keep this bit of code here, and I'm going to add this into here just to test this bit. Okay, so select the number. If the first ones match, if they don't, then it will message something else. Okay, so number didn't match. Okay, so you can kind of see that because position 1 didn't match, it didn't work. But if I did 1, 2, 3, 4, for example, the numbers do match because the first position does match. Now you could, like I said, write this as a massive series of code, like so. Okay, and that is one way that it can be done. So that's position 1. Let's do that one position 2, and then this one position 3. So you've got 1, 2, 3, 4. So let's have a look. So numbers didn't match, numbers didn't match, numbers didn't match, numbers didn't match. Okay, so that, okay, it's not going to be a true reflection of what we're going to want to see. We actually want to see the coding where it's telling us this. So, I mean, you could do this where you said the numbers match, else the numbers didn't match. You could even put in here the first number didn't match, the second number didn't match, the third number, etc. But there is actually a more efficient way to do it. Now, as I'm going through this video, I would like you to kind of do this along with me and to add your coding with me. You can pause it, you can come back to the video, and then you can have a go at doing it yourself. Ideally, you would solve this all by yourself, so that you have the coding and you've got a little bit more confidence with what you can do to create this coding. Okay, so at this point, see if you can think of your own solution before I reveal what solution I have selected for doing this. Okay, now assuming that you have gone off and you've had a look at what you can do, instead of having it where you would say compare the numbers, if I added my positions here, like so, we can kind of do what I did before. So let's check and see if we've got everything in the right place and we're happy with it. So if I did 1, 2, 3, 4, 5, like that, okay, so that's the correct answer. However, it's looped. The reason it's looped is because they are not completely equal to each other, which is what we want to see. Now, what we really want to see here is we want to see this check the positions of each number going up by 1 each time. Now, I showed you at the start of the video how you could do that with I in range. I in range can be used as a variable itself. So if I did for I in range and I selected a range of 0 to 4, don't forget that I've chosen 4 because we've got 0, 1, 2, 3, 4. It doesn't include 4. 4 will not be used. Same as when I did that I in range at the start, it didn't include 101. If I then replace these with I, you can then get it to increase the position each time, and it will loop each time. So let's say that number is correct. So let's run that. Let's see what happens. Colon. Remember the colons, and then tab across so that they are part of that loop. Now if this coding is all correct, we should see that it will loop 4 times. So it's done, that number is correct, 1 is correct, that number is correct, second position. Okay, so in the coding that would be position 1 is correct, position 2 is correct, and position 3 is correct. So we can see that that is working. Okay, so that is a really, that is a really nice solution for that. It's a much shorter code and it works very efficiently. Now the next thing we want to do is we want to actually be able to tell the user what their position is and what their positions are and how they work. So how those positions are, well, let's say we wanted to have it so that the user can say what position and the number of positions that they got correct. Because at the moment, we don't really have that. So what we're going to do is we're going to have a list. Now a list is useful to store some information. So again on here, generate a random 4-digit number. We can do that. The player has to keep inputting 4-digit numbers until they guess the randomly generated number. We've got that. After each unsuccessful try, it should say how many numbers they got correct, but not which positions. At the end of the game, should congratulate the user and say how many tries it took. So we've done this first bit. After each successful try, it should say how many numbers they got correct. So let's have a look at how we can add it so we can tell the user how many numbers they've got correct. We're going to use it with list, and we're going to add some more functions. Okay, so a list, you can add to a list. So if the user is getting it correct, what you want to do is append the list. So what you want to do is you want to put an item in the list. Okay. So what we're going to do is we're going to do append.list. So the point of this is that it adds to the list each time. So every time it does this bit of the cycle, it adds an item to the list. So it adds I to the list. So whatever range number is I. So I'll add whatever that I number is. What we also want us to do is to loop a part of this. Now, what we want it to do is loop basically how many numbers they got right. So to do that, we need to be able to tell them what the length of that list is. Now to tell someone what the length of something is, what we want to do is go to, let's say print here, to get list so it's going to basically put number in there, and we're going to use a new code. So we want length of the list. Okay, so I'm going to do this as capital L and capital L here because list is actually a function. So we're going to do list. Actually, no, I'm going to change that. Let's do correct. That seems to make more sense. Let's do correct as the variable. Okay, so correct is the variable. So it's going to tell us you managed to get, and then it's going to put a number there. And then we're going to do just a bracket here for the S. So if it's more than 1, it'll be S. If it's not, then it's just 1. So you managed to get, for example, 3 numbers correct. Let's have a look, see if this works. Invalid syntax. Correct equals. Okay, so equals an empty list. That's what we want. Let's try that one again. And I've missed my brackets. There we go, right. Ooh. Ooh. Append is not defined. Okay, so then we add list.append. So I changed the append and list round. And change my variable here to correct. Okay, so that number is correct. This is not equal, this is not equal, this is not equal. And then you manage to get one number. Numbers, correct. And then it goes back round. So at the moment, my coding is basically telling them, this is actually kind of what the extension goes on to ask you to do, that for each of them it tells you if it's equal or not. But for this one, I'm going to get rid of the else for now, because we don't actually want it to do anything else. And then I'll put this over here. Okay, so that number is correct. You managed to get one number's correct. Okay, so at the moment, we've managed to do that next bit of the task. So how many numbers they got correct, but not which position they got right. At the end of the game, should congratulate the user and say how many tries it took. Now the next bit we want, now the next bit on here we want is how to get them to have their bit of code come up. So what we want is, we want that bit of code that tells them how many rounds they've done basically. So if we add rounds equals 0, there's no rounds. Actually no, we'll start on 1, because the first time it goes round it won't count it, so it'll be 1 round to start with. So round 1 is this one that they're going to start with, and then for each round you want to add an extra round. Now what we want to do is have just else here, because even if they get it wrong or they get it right, it needs to add to that. Okay, so if we have it here, we're going to basically not use else actually, we're going to add it. So here, when it gets to this point of our coding, we're going to do rounds equals rounds plus 1. So what it will do is it will take the rounds and it will add one number to it. Now if they manage to complete the game, it's going to break out the loop because the computer number will be equal, which breaks the loop, and it's going to print let's say well done, the computer's number which was, and then here we can actually put the computer number this in, and then we'll do the rounds. Don't forget to put the word rounds at the end, because otherwise it's not going to actually have that. Remembering that the variables aren't printed. So let's have a look. Brackets again at the end there, and speech marks. There we go. Okay, so select a 4-digit number. I'm going to just start with the right one to start with. So I've got that number is correct, that number is correct, that number is correct, that number is correct. You managed to get 4 numbers correct. Well done. You guessed the computer's number, which was 111, 111, etc. You completed this in 2 rounds. Now if we're getting that, what we want to do is if we change this to 0, and let's see what happens with our coding this time. Excellent. So, well done, you guessed the computer's number within one round. So with the coding that I've got here, I would want rounds to be 1 here. So it adds just 1 to it. So it means that first round, and I got it right. Now this is where we start adding those kind of final bits, because at the moment this isn't random. So this is where we want to have a rand int brackets, and we select between the numbers. Now as I mentioned at the start, you want to have it between 2 numbers, and these are 4-digit numbers. They are the smallest 4-digit number and the biggest 4-digit number. So if I do this, and then you manage to get 0 numbers. Okay, let's try this one. And so now you can see why it was important that we had those in there before. Okay, so that's why I started with choosing that number, because otherwise we'd have to do this every time until we finally got the number correct. So I've got 2 numbers correct. Don't know what positions they are though. I've just got 2 right. Now if I go back through again, you'll see that I've got 2 numbers correct, but I've got 4, 5, 6, 7 here correct, and 4, 5, 6, 7 here. So what it's done is it's added the numbers to the list, but hasn't actually reset the list as an empty list again. So if I did 8906 again, all of a sudden I've got 4 numbers right, and now I've got 6 numbers right, 8 numbers right, which isn't possible for a 4-digit number. So what's happening is it's adding to the list every time, but not taking anything off the list to reset, where it resets the list each round basically. So it prints it and then it will make the list empty again. So let's add correct equals empty list again. So what it will do is it will print the length of correct, and then it will reset it ready for this point here. Because once we've got the correct number here and the number's correct here, it will break out the loop, and then we don't use correct again down here, so it will still work for us. Now just to test this out again, let's just change this to 111 again. No, I don't want random. Make that a string. Okay, so you managed to get 1 number correct. Okay, so that one's correct, that worked, so it knows that I've got it correct, and it did it in 2 rounds. And then we just want to make sure that everything is working when we do the round int. And then we'll set it between 2 numbers. Now because we're testing this, we can get it to print computer's number. Okay, so right at the start it's going to tell us what the computer number is so that we can test it and we can see if it's having the right effect. So if I did 8, 9 and 1, 2 for example, I would expect to see 3 correct, which I have. Now if I then did 8, 9, 0, 0 for example, I should see 2 correct. You managed to get 2 numbers correct, and then it's reset that list for us. So this is having the exact effect that we want, and we've managed to congratulate the player at the end of the game. So let's test that one. So it's always important that you test these. So let's put the correct number in, which is 8913. So 4 numbers correct, game ends. So that's it, game finished. And it told us the amount of rounds. Now looking at these, now that we've had a look at that, see if you can complete these extensions to see if you can add more depth to your game. And if you want a real challenge, you can try to create one that's a little bit like my one, which is here. So mine's done in a slightly different way. And what I've got here, if I show you the full coding, is I've got mine where it does the rounds, adds the rounds, and this bit works pretty much exactly the same as your one. But I've added another part here. And what this is when you run it, if someone inputs an incorrect number, it comes up saying that that number does not contain 4 digits. So it tells the user you've entered an invalid amount. So it's a way of defending your system so that they can't just put anything in there. Okay? And also if they start putting letters and things like that in there, it will never be valid. So it knows that it's an invalid response. So try adding that to there. I've got this coding as well, which you can see on the video, so you can see what I've done and how I've created my code. And I hope that has helped you understand a little bit more about how you can create the Mastermind challenge.